The purpose of this video is to demonstrate how to conduct a chi-square goodness of fit test in SPSS. In this data set, we have the variable party identification, which has 3 levels: Democratic, Republican, and other. And we have a variable that represents the frequency of each party identification in our fictional sample. So first we want to weight the cases by the frequency. Since they are already tabulated for us, this tells SPSS that each row represents the number of cases in the frequency column. So we must do this first if the data are already tabulated in this way. We click OK, we weight the cases, then we go to Analyze, Non-Parametric Tests, Legacy Dialogues, chi-square. And we enter in party as our test variable. Now if we want to compare our sample, or more specifically the population from which our sample was derived, to a situation or a population where all the categories are equal, then we leave things as is. However, if we want to compare our sample distributions to a different sort of population distribution, then we need to specify the expected values. So we click on Values. So let's say we wanted to compare this to a situation where we have 60% Democratic, 30% Republican, and 10% other. We have in our data set a total of 159 cases. If we expected 60% of those to be Democratic, we would expect 95.4 of our cases to be Democratic. Now we do the same for Republicans. We have 159 cases. If we expect 30% of those to be Republican, then we expect 47.7 Republicans. 47.7. Add, and then finally, if we have 159 cases and we expect 10% to be other, then we expect 15.9 as our expected frequency for other. Once we've entered that in, we can run the chi-square goodness of fit test, and we see that in our data, although there are some discrepancies between our sample distribution and the expected population distributions, such that Democrats seem to be relatively underrepresented, Republicans seem to be relatively overrepresented, and the other category also seems to be relatively overrepresented. By the conventional cutoff of 0.05, this is not a statistically significant departure from the expected values.